Hi, and welcome to today's lesson on circuits. Here we're going to take a look at a complex circuit, and we're going to learn how to calculate the equivalent resistance, which means the total resistance of the circuit as a whole. So let's take a look at what we have here. Starting with an output voltage of 30 volts, and then we have one resistor in this top branch of our loop of 60 ohms, and we have two resistors in this branch of our loop of 10 and 20 ohms respectively, and then a fourth resistor after our current meets back up of 10 ohms before our current arrives back at its starting point here at the end of our circuit. So in order to calculate equivalent resistance, we need to use Ohm's law, and that's really the most important law to keep in mind whenever dealing with circuits. And that law is V, which is voltage, is equal to IR, current times resistance. Your voltage is equal to your current times resistance. So now let's take a look at how to calculate our equivalent resistance for this circuit. First of all, if we have two resistors in series, for example, resistors 2 and 3 here as part of the same branch, to calculate the equivalent resistance for those two, we can simply add up those values. Resistors in series, you add the resistance to find your total. So the resistance of resistors 2 and 3 will equal the resistance of resistor 2 plus that of resistor 3, which for this problem is going to be 10 ohms and 20 ohms added together for a total resistance for those two of 30. So we can look at this branch of our loop as if there's one 30 ohm resistor there. Now, if we look at these are what we call in parallel with resistor 1. So those two run in the same direction, and if we think of parallel lines, visually it looks the same as parallel lines. We see those two sets of resistors are in parallel to one another. To calculate resistance in parallel, we have to use the reciprocal function, and we're going to have 1 over our equivalent resistance of those three resistors, resistors 1, 2, and 3, will be equal to 1 over the resistance of resistor 1 plus that of resistors 2 and 3 together. So in this case, for the math on that, we have 1 over 60, which is the value for the resistance of this first resistor. And then resistors 2 and 3, we already calculated, has a resistance of 30 together. So we'll have 1 over 30 for that second part. Now, when we simplify these, 1 over 60 and 1 over 30, we have to find a common denominator. Common denominator is 60, so we can multiply both of these by 2. And it's 1 over 60 plus 2 over 60, which is going to be equal to 3 over 60. This we can reduce to 1 over 20, which means the resistance of resistors 1, 2, and 3 is going to be equal to 20. So R1, 2, 3 equals 20. So now we take our value for the equivalent resistance of these first three resistors all together. And if we look at resistor 4 is in series. And what do we do when we have resistors in series? We add them together. So we're going to take that resistance of resistors 1, 2, and 3. And to find our equivalent resistance for the entire circuit, we have those first three plus the fourth one, which gives us a value of 20. Plus 10, and our equivalent resistance for the entire circuit is 30 ohms. Now the reason that it's so important for us to calculate equivalent resistance is because that's the value that we're then going to plug back into Ohm's law in order to find out the current passing through this circuit. And we'll see that in our next video, which covers the rest of this circuit where we look at calculations for current coming out of our voltage source, and we'll also calculate current passing through specific resistors in each branch of our loop. For more information, you can visit our website at www.sandersontestprep.com. The link is in the description below. Thanks.